and government systems, and are often the only Web applications and web servers now form much of the attack surface of business and government systems, and are often the only technology exposed to the Internet. As such, a pen tester needs to have a good understanding of the various technologies used and how to test them. Web servers come in many forms. They may be static HTML servers, serving up information that changes only when the website is updated. They may be active servers, running one or more of many different active languages. They may be content management systems, providing easily scripted web content through one of a number of CMS solutions. In addition, there are a vast number of web applications which we may come across. A web server may present just an HTTP interface, or may have a number of interfaces supporting not only the web service, but other services also. It may be one of many named web servers on a single host. As a pen tester, the more we understand of the vast landscape of web services, the better placed we are to practice our craft. I'm Malcolm Shaw, and I've spent a career helping governments and businesses protect their networks and systems against cyber attacks. In this course, I'll be introducing you to a variety of web technologies. We'll start by looking at various tools to enumerate the web platform to find more than the standard access vectors. The most important tool for the web tester is Burp Suite, and we'll take a good look at how we can use that to proxy, intercept, modify, and repeat messages. We'll be using both our LinkedIn Learning Lab and some of the servers that are in the standard Hack the Box lab. The latter servers may or may not be active when you're watching the course, but the LinkedIn Lab machines will always be active for you to get hands-on. We'll use these labs to do penetration testing to gain access to web applications, to access information from the server, and we'll gain command shells. We'll look at a variety of exploit techniques that we can use when web testing. This is one of a series of advanced courses in pen testing, which together provide the learning pathway to taking your offensive security certified professional qualification. Now let's get started with advanced web testing. This is a practical course, and during this course I'll be using Kali Linux-based tools to do testing, using servers on the LinkedIn Learning Lab that was introduced in the Advanced Kali Linux course. You should be competent in Windows and Unix host technologies, as well as having a good grasp of network protocols. A good understanding of HTTP would be an advantage. You'll need to have a good working knowledge of Kali and some hands-on experience of testing. You should have a working knowledge of web testing tools, in particular Burp Suite, and you should have taken the Ethical Hacking Web Servers and Application course. You should have a basic knowledge of scripting languages such as PHP and Python. Websites are the main way in which information is presented out of computer systems, and increasingly the main way in which users interface with application systems. There are many forms of website, and to be a good web application tester, we need to have a good working knowledge not only of the underlying protocols used for web access, but also the structure of the websites. I introduced the basics of websites in my ethical hacking course on testing websites and web applications. Let's just refresh ourselves on what we learnt about how websites are presented. A web application is built using HTML and script code, running on a web server that offers an HTTP or HTTPS protocol access, the more recent WS and WSS WebSocket protocols, or the experimental QUIC protocol. It will likely use a backend database server or some form of flat file for content. A user will connect to the application from a browser, which may be running on a desktop, a laptop, or a mobile device. The web application may want to authenticate the user, and to do that, have some form of back-end authentication system such as LDAP. It's good practice not to expose a web application server directly to the internet, and so a web proxy will be placed between the user and the web application. The proxy server takes user requests and sends them to the web application, and takes web application responses and returns them to the user. A web proxy is designed to be secure, and is a much safer internet-facing system than a full web server. Early web applications tended to be mainly written on the server side, with forms being used to request data. Nowadays, much of the code is client-side, often supported with client-side data stores. While content management systems have a standardized web folder structure, the folder structures for custom-built web applications will be application-specific. Also, individual web servers have their own default folder structure. This may be changed for production, but understanding what a default website would look like for each type of server is a good start. A website exists as folders on a host, with the home page of the website on a typical Linux installation of Apache being located at var www.html, and on a typical Windows installation of IIS being in inetpub www.root. The hypertext markup language, HTML, is the basic building block of a website. A web page starts with a declaration that the page is indeed HTML, written as !doctype HTML. After that, the basic component of a web page is an element of the form element/element, with element-specific information in between the start and end markers. The start marker may additionally have attributes in between the open and closed brackets. The element start is sometimes known as a tag, and there are a number of standard ones such as title, the H tags for headers, body, and the P tag for paragraph. Another useful tag is a href, which enables a web page to reference another web page through a hyperlink. Web designers have gone much further in the way in which web pages are crafted in order to ensure a consistent application of styles. We can use the style element for the page or for the whole website. This can be included in the page or more usually in its own file external to the HTML file. The full external styling approach is known as cascading style sheets, and we won't be spending much time looking at them. We'll also see tables and forms appearing in many web pages, particularly those we're interested in. We need to understand how the forms pass data to be validated and processed, as this can be an area of weakness in some sites. Forms have their own form tag and are constructed with various elements to enable data input, and often have div elements which define areas of the page. There are also XML, PHP, and JavaScript tags, which allow active code to be included in web pages. Here's an example of a call to an external JavaScript file and an embedded line of JavaScript code. One of the important elements of a PHP-driven website message exchange is the PHP session ID, and this is something we'll use during our testing to enable us to work inside PHP sessions. We'll be seeing more of active code as we progress through the course. In addition to understanding what the target looks like and how it's built from a static perspective, the web application tester also needs to be knowledgeable in the message protocols used by the application when it's operating, and particularly the two common protocols HTTP and HTTPS. HTTP is a stateless client-server protocol which can be used from a browser or programmatically between hosts. An http://URL will establish a TCP connection on port 80, as we can see here. And HTTPS:/ will establish a connection by default on port 443. HTTPS will be used to set up protected data transfer using TLS packets. It's not unusual to see a web server set up on a different port, such as 8080. An HTTP exchange consists of an HTTP request message, which is sent to the web server, and an HTTP response message which is returned. In an interactive session, the HTTP response will provide data for the user which needs to be displayed, i.e. an HTML web page. We can see the selected response packet in the bottom panel is a zipped text HTML page. GET is one of 8 standard request commands or methods defined in HTTP. The GET command allows a user to download a web resource from the server. This will often be a web page specified by a file name. Omitting the file name will cause the default first page to be returned. The head request is used in the same way as GET, but will download just the header or metadata, This is commonly done to check the last modified date of the page, to check against a locally cached copy. The post command allows a user to upload items to the server. This is commonly used to send form data to the server and is the key message that's of interest to pen testers. The trace command requests a diagnostic trace of the actions taken by the server. The options command asks the server to return the list of request methods it supports. The connect command causes the proxy to connect to another host. This is often used to make an SSL connection through the proxy. Two important commands when doing web testing are the put command to send data to the server to be stored, and the delete command to delete the data. These are often not used in production systems for security reasons, but if they do exist, then we can likely take advantage of them. There are 7 common status codes. 200 indicates that the request was processed without any problems. 301 means a redirection for pages that have been moved. 400 is a bad request. 401 is unauthorized. 403 means access is forbidden. 404 is an unknown page. And 500 is an internal server error. When looking at a host, it's easy to assume that whatever is presented as the default website is the complete service, but this is often not the case. The server may have many different web trees which we can access using different URL extensions to access their root pages. And we also need to take into account that Apache allows multiple name-based websites to be served from just one IP address. Virtual hosts are accessed not by their IP address, but by their URL. DNS will resolve the IP address, and the virtual host server will direct the incoming connection to the required virtual web server based on the URL. The host will always have a primary virtual website, which will respond to any request not specifying a name-based website. We can see here www.domain1.com through to www.domain5.com, all residing on the same host. As a penetration tester, finding all the vhosts that run on a host is important. Any one of these websites may contain vulnerabilities that allow access to the underlying server, and hence to all of the web servers being run. Unfortunately, identifying that a server is a named site server and identifying the websites on it is a challenge, and not something that appears immediately obvious with standard enumeration. DNS enumeration tools and some online services such as the Virtual Host Finder from pentest-tools.com may be useful, but in practice still leave a lot to inspired guesswork. Let's take a look at one of the servers on our LinkedIn Learning Lab on 10.10.10.13. Sadly, the online service isn't able to access the server. The best option if it's feasible in your testing scenario, and if you have the time, is to have a passive scanner look for the websites being visited and record their IP address. If you see more than one website using the same address, you know they're name-based websites. It's worth noting that an Apache server may also host multiple virtualized websites, each with its own IP address, by using a different network interface card. From a pen testing perspective, these can be enumerated as though each runs on its own server. This is nowhere near the challenge of name-based websites. We can see here that 10.10.10.13 is currently showing only the default Apache page. However, we know that the server is named Kronos and that it's a host server in the Hack the Box domain. In order to check for virtual hosts, we might guess that there's a server called Kronos.htb. I need to resolve the name into its IP address, so I'll add this to my etc. hosts file. Now we know 10.10.10.13 is a name-based web server host. Let's find out what other websites exist on it. To do this, we need to use the dig tool and do a zone transfer from the server. Dig provides a list of all named hosts for the Kronos.htb domain: admin.kronos.htb, ns1.kronos.htb, and www.kronos.htb. We've already seen www.kronos.htb, so now let's see what we can find in admin.kronos.htb. I'll add this to my etc hosts file. And we can see this is a separate web server, and we get a login for the admin site. Enumerating for virtual hosts is a challenge, and at this stage one which requires inspiration as much as analysis. Much of the professional web app testing is done using Burp Suite, and this requires that we proxy our web messaging through it. Let's open Burp Suite and get it set up. I'll ignore the pop-ups for the moment. We won't update Burp Suite. I'll take a temporary project and I'll use the Burp defaults. Let's start. Burp Suite comes up with interception on by default, but we don't want this when we're using it just as a proxy. I'll select the Proxy tab and switch Intercept off. I'll select Options, and we can see that we have a running proxy listener on port 8080. Burp Suite starts up with spidering off by default. I'll select the Spider tab, and we can see that spidering is paused. We'll leave it off for the moment, but if we switched it on, then we'd automatically spider any page we encountered. In proxy mode, Burp Suite won't capture traffic unless we give it the targets. Let's select Target, Scope, and we can see the filters that we can set for capturing incoming and outgoing messages. There's currently no targets configured for capture. Let's assume we want to capture 10.10.10.5. Then we just click Add, and we enter 10.10.10.5. We've got Burp Suite set up as a proxy for all traffic, but only to capture 10.10.10.5. Now we need to set our browser up to use Burp Suite as its proxy. Firefox will remember the last settings, so it may or may not be configured for proxying. Currently we're not, so I'll select the Tools icon, Preferences, Advanced, Network, and Settings. We have 4 options. The normal ones we'll use are No Proxy and Manual Proxy. I've already got the proxying set for this machine, 127.0.0.1, and for port 8080. I'll click Manual Proxy. I'll select OK, and we're all set to go. I'll navigate to 10.10.10.5, and we can see the default page. I'll navigate to 10.10.10.22, and we can see its default page. Back in Burp Suite, at the target sitemap, we can see that we've captured traffic for 10.10.10.5, but we've no traffic captured for 10.10.10.22. As with any pen testing challenge, enumeration is the key to success. It's really important that we have visibility of what we're testing in as much detail as possible. That means looking beyond the obvious, which differentiates pen testers from script kiddies. When testing a website, it's fairly straightforward to spider through the site, going from one page and enumerating all the pages it calls, and then all the pages they call, until we have a linked tree of all pages in the website. We can then check each page for known vulnerabilities. However, For advanced testing, we want to see what exists in the website, even if it's not directly linked up to the default route. This is often the case when the website consists of multiple functions, such as an administration or management portal, and when it has hidden test pages. Let's look at what Kali provides to help us find out what's inside a website. I'm looking at the Hack the Box Popcorn website at 10.10.10.6, which provides a simple HTML scripted page to say the website works. There's no content accessible from the main web page, and no indication of additional pages. I've started Burp Suite, so let's set it up to proxy Popcorn. I'll go to Proxy and turn Intercept off, and I'll go to Target, Scope, and I'll add 10.10.10.6. I'll refresh the page, and then we can go back and have a look at it in Burp Suite. We can see the message, and the website has been added to the left panel. We can expand it. We can also right-click and select spidering. As we'd expect, spidering the site doesn't identify any new pages. Kali provides a command line tool called GoBuster to do dictionary-based testing to identify additional pages on a website. Let's run GoBuster on this site and use one of the Dirbuster preloaded dictionaries. The two basic parameters we need to provide are the URL or IP address and the word list to use for the dictionary attack. We can also use the X switch to look for specific types of files. We'll check for PHP files. Okay, we'll let that run for a minute or so. As with any dictionary attack across a network, the speed of finding additional access points depends on the size of the dictionary and the speed with which a response is provided. Also, if we get no results, we can't guarantee that there's no additional access pages, just that they're not in this dictionary file. Okay, we quickly found two additional pages, index and test, and a test.php script. With a bit more patience, we've also found an additional folder called torrent. These are status 200 and 301, so we can access them. Test and torrent sound interesting. Let's check them out. The test page brings up a PHP information page, which provides a fair bit of detail of the system configuration. At the top, we can see it's using PHP version 5.2.10 on a Ubuntu 6.10 server. We can see in the details pane that it's using the Linux 2.6.31 kernel and that the host is called Popcorn. A little bit further down, we can see that this is a hardened PHP system. And a bit further down still, we can see that it's running Apache 2.1.12. This is very useful information for us, so that we can scope out the kind of testing we might look at conducting once we've finished reconnaissance. If we go back into Burp Suite, we can now see that we've spidered more content, the test page and the test PHP file with their document type definitions. It's also showing linked external pages. The torrent page shows that this system has been set up to act as a hosting server, enabling files to be uploaded into the torrent repositories for subsequent remote download. The page allows for the torrent administrator to log in. We now have a start point to look for ways to bypass authentication, such as trying for an SQL or command injection. Back in Burp Suite, we can now see that we have many more pages available. In particular, under the torrent folder, we can see upload and user folders, and these will be worth exploring. We get a web folder directory, and we can see that both PNG and PHP files have been uploaded. Let's look at the users folder. The users folder requires authentication, so we get the login page presented again for us to sign up or log in with existing credentials. Back in our GoBuster terminal, we can see that with even more patience there's another page being identified called rename. We didn't see this in the spider output, so let's check it out. A fairly common trick is to upload the file as a .text and then rename it. Having a URL capability to do that might come in quite handy. When running GoBuster, there are many options we can set. One of the key options is setting the number of threads. We use the -T switch to increase the number of threads that we can run concurrently. Determining the optimal number of threads based on your processor and memory configuration and the other workload on your system will be something that you might want to do, as this does affect how quickly you can enumerate the website. We can also use -V. This will print out the current folder being tested. This is sometimes useful to see how well the scan is progressing, but it creates a lot of output and can mask the useful information. If we know the website credentials, we can use them to get access to protected pages, which will open up additional pages behind the authentication. This is useful in white hat testing where credentials are provided. We can also capture and reuse the cookie to give us access to a session. Let's look at another tool for enumerating websites called Dirbuster. We can find this in Applications, Web Application Analysis, Web Crawlers and Directory Brute Force, Dirbuster. Dirbuster is a graphical interface for doing a dictionary or brute force attack on a website to identify new top-level pages. It's the GUI form of GoBuster. We enter the URL, say http://10.10.10.22, and let's leave the work type and scanning method the same. We'll increase the number of threads to 25 to increase the speed of scanning. We'll need to select a dictionary to use. Let's use the lowercase medium text dictionary that comes with Dirbuster. Dirbuster is set by default to brute force both folders and files, and PHP file types are selected. Right, we can start. We can see in the main panel the folders that we're finding as we go, and icons comes up fairly quickly. We can see the progress at the right-hand bar for each stream of work, and at the bottom right we can see the folder names we're testing for. If we look at the top, we can see we've identified 2 folders and no files so far. And if we go to the Results tab, we can see a tree view of what we've found. Okay, let's leave this running. Let's take a look at the Options menu and Advanced Options. An Advanced Options window pops up with 5 tabs. We're on the first tab, which is HTML parsing elements. This shows which elements of the page Dirbuster will extract links from. We can right-click on a link in the middle pane and we get an option to remove it. Below this pane, we can add another element. We can also see above this pane that we're not going to process any links to image files. Let's check out the authentication options. This is where we can add a user ID and password to get access into an authenticated area of the website. The next tab is HTTP options. At the top we can add custom HTTP headers. It's not uncommon to find HTTP servers using custom headers including x powered by, x cache, x pingback, x forwarded for and x HTTP method override. WordPress, for example, uses x powered by and x pingback. Note we have Dirbuster announcing itself as the user agent, a clear giveaway in a red team that the reconnaissance is underway. This is one field you may wish to change. We're not running through a proxy right now, but we could stage this through Burp Suite if we wanted to inspect the messages. The next tab is Scan Options, and we can set the timeout value for the message and also provide an upper limit on the number of requests per second if we want to be a little bit stealthy. The final tab, Dirbuster Options, allows us to update Dirbuster and set the number of threads to run and the file extensions, duplicating what we can do from the main screen. Okay, let's leave Options for now. Dirbuster provides the same capability as GoBuster, but using a graphical interface. These tools form an essential part of the reconnaissance phase of a web application pen test. There are a few more tools we can use to enumerate web servers and look for website pages that are worth knowing about. Let's take a look at a couple using our LinkedIn Learning Lab servers. The first tool we'll use is a simple fingerprinting tool called WhatWeb that provides a basic but very fast profile of the website. I'll use it against the server on 10.10.10.5. We can see we'll be working with an IIS 7.5 server running ASP. It appears to be under construction. WhatWeb can also check all websites on a subnet. At 10.10.10.13 and 22, we can see that we're dealing with Apache 2.4.18 servers, and both present the default Apache page. We can see at 10.10.10.8 that we have an HFS 2.3 HTTP file server, and at 10.10.10.29 we have an Apache 2.4.7 server, again presenting a default Apache page. WhatWeb comes with a large number of plugins for specific websites and applications. We can see these using the -L switch. Here we see the plugins for all the web servers and applications that WhatWeb knows about. There are plenty of them. We can get the full information for a specific plugin using the Info Plugins switch. Here we see the details for every plugin that mentions CGI. When time is of the essence, we can use WhatWeb to rapidly kickstart our web testing and gather valuable information for subsequent targeted testing. Another tool we can use runs in the Metasploit environment. This is an auxiliary scanner called DIR-Scanner. Let's set it up to run against 10.10.10.22. Okay, we've found it, so let's use it. Let's have a look at the options. We can see that Metasploit as a standard is using the default WMAP dictionary. We'll leave that, and we'll also leave it to run from the web root. We'll need to set our hosts to the server IP address. Okay, we'll run the scan and come back to it shortly. We can see that with the WMAP dictionary, we've found just the icons page. The effectiveness of these tools is dictated by the dictionaries they use and how efficient they are at using them. DIR-Scanner is a good option when working in the Metasploit environment. I've switched to the Hack the Box lab to look at a couple of different servers for the next two tools. Derby is another dictionary-based enumeration tool which is simple to use and runs relatively quickly using a built-in set of common folder and file names. Let's run it against the Nineveh Hack the Box server. Derby runs from the command line and in its simplest form takes just the URL as an argument. Okay, we can see it's picked up its own common dictionary and is running through it. The current word being processed is shown at the bottom of the terminal screen. Derby found the files index.html and info.php, and with a bit more patience on my part, found an additional page called Server Status. There's a number of options we can set for Derby. If we just run the Derby command with no arguments, we get the help. The word list file is the second command line argument, and we can run using multiple word lists by separating them with semicolons. Derby provides a number of word lists as standard. Derby comes with a range of word list files focused on specific searches and web servers, and the vulns folder provides a number of server-specific known names. Back at the options, a useful one when deep diving a specific known file type folder is to append an extension such as HTML, CGI or PHP to the end of the words. We can do this using the -X option. WFuzz is another tool in the Kali repository, and while it's not specifically designed to look for hidden pages, we can use it for this purpose. WFuzz needs to know the word list to use and the URL to start with, and we can also tell it what responses to ignore. We'll ignore 404 page not founds. We've used the C switch to get color output for the different response codes. We can see it's detecting various lines of text, which we're not interested in, as well as valid folders. We can see images, uploads, PHP, CSS, dev, and JS folders being detected. WFuzz is very fast, and it can be used to get a top-level shortlist of URLs to test. You'll quickly get used to your favourite tool, and you'll develop your own dictionary files for each type of target. Kali provides a good range of word lists across its tools, and you can add to these as you progress. We've got a number of tools that we can use for crawling or spidering a website, including Burp Suite. Given that we use Burp Suite as a proxy, it makes sense to have it do the spidering for us. Spidering isn't an attack, it's just automating the viewing of a website by looking at every page. I've started Burp Suite. I just want to proxy, so I'll go to Proxy and turn Intercept off. I'll then go to Target, Scope, Add, www.parachuting.com. Burp Suite is now set up, so let's go to Firefox and go to the website. We can see that we've already opened a number of web pages on the site. Let's expand the main parachuting page and see what pages have been identified so far. Okay, let's select it and select Spider this host. We can now see additional pages being added into the tree, both outside of the website and inside the website. We can also see that this is a WordPress website. As we spider the site, we can see that Burp Suite is scanning the web pages we've visited to check for issues. These are shown on the right. We've got a pop-up because as we've been spidering the site, a form has been found which requires information to be entered. We can ignore it. If we select the Spider tab, we can see the status is that Spider is running, and we've made 800 or so requests, and we're still going. We've now finished spidering the website, having completed over 3,000 requests and transferred almost 150 megabytes of data. Spidering isn't a quiet exercise. We've got a large list of pages in the website that we can look at. Of course, if we wanted to see the web page itself, we can select the page we're interested in, say Shreveport 1200 by 400. Let's look at the response and select the Render tab. The web page then renders in the bottom panel, and we can scroll down to see it all. We can set the spidering options in the Spider tab. I'll select Options. We can see the first default option is to check for robots.txt. This is useful as the contents of robots.txt can sometimes indicate sensitive pages that the website owner doesn't want to be indexed by web robots. We can see we have a robots.txt file, and by looking at the response message we can see that WP admin is not indexed. Nevertheless, looking down the tree, we can see that Burp Suite does not honour the robots.txt, and so we've spidered it. When we select it, we can see it contains PHP files, which may be useful for our testing. Back at our spider options, we can see some other options which allow us to limit the number of less important issues. We can also request that the root of any referenced page be checked. This can potentially realize a completely new branch. We can also detect additional content by selecting non-parameterized GET request for dynamic pages. Dynamic pages usually respond differently if the expected parameters are not received, and checking this option may detect additional content and functionality. We set to spider up to 5 hops from any base URL. Setting this to a lower level may assist with spidering websites with large amounts of individual items referenced from the same base point. Websites will often have forms that request information and then continue through to conditional branches. We can set options to automate some of these form requests. We can see here a number of standard field names which can be automatically populated. Below that, there's a special configuration section for logon forms requesting credentials. Here by default we'll request user input. This allows us to enter credentials if we have them. Alternatively, we could code in default values of, say, admin for the fields username and password, and allow automatic submission. The next section enables us to control the number of threads and the page timeout, both of which affect performance. More threads will spider more pages concurrently, and a lower timeout on fast networks will increase the rate of checking pages. Finally, we can customize the HTTP header that's sent when we spider pages. This may be useful when target applications expect certain user agents. Note we're also set to spider using HTTP 1.1. If we don't set this, Burp Suite will default to HTTP 1.0. Sometimes the root of a website gives us nothing even after spidering. I've set Burp Suite up to proxy for the hack-the-box jail server on 10.10.10.34. I'll navigate to 10.10.10.34 and we can see the default page, a jail room. Back in Burp Suite, we can see the page in the website tree and in the messages pane. The request details are at the bottom, and we can click on the lower response tab to see the response. I can open the website, but there's no other pages to see. I've already brute forced jail with Dirbuster and found another page called Jail User. Let's navigate to it. We can see that this provides a folder listing. We can see that the Jail User page has appeared on the tree. If I expand it, we can see under it a root and a dev folder. If I expand the dev folder, we can see there's just the direct level below. I'll now right click on the top level URL and select spider this host. We immediately see more pages being found, appearing in the middle message pane and being added to the tree, including external pages referenced by the website. If we expand the icons branch, we can see that we've detected and spidered another level called small. Burp Suite is a powerful tool for the web tester, and it makes spidering simple. A full port scan with Nmap takes a while, and so it's useful to have a tool that can scan a host or subnet rapidly to determine open ports, and then we can follow up the results by deeper scanning with Nmap. Mass Scan is such a tool, but it doesn't come preloaded into Kali. Let's install it. Mass Scan is now installed, but we have to build it. This takes a short while. We'll let it run. That's done, and it's created the mass scan binary in the bin folder. Let's use it to test all 65,535 ports on one of our hosts. We've selected the TON0 plaintext interface, selected all ports, and selected one host at IP address 10.10.10.61. We can see the progress, so we'll let it run. A couple of minutes later, we've tested every port and we've found 5 open. We can Ctrl Z to finish and move on to some deep probing of these 5 ports. Let's take a look at the Nikto tool and how we can use it to look for avenues of attack in a web server. I'll run this against the Europa server to see what it finds. In its simplest form, we just need to specify the host address, and Nikto will look at the web server and root website. The first thing we see is that the target is running an Apache 2.4.18 web server. We can see that the server leaks inodes via e-tags. Usually we can ignore this as it's a legacy check and it's nearly always a false positive. Even if it isn't, for most websites it's a very minor issue. Nikto advises us that the anti-clickjacking X-frame options header is not present. It also advises that the XSS protection header is not defined, and that the website as a consequence may be vulnerable to some form of cross-site scripting. Similarly for the X-content type options header. There are no CGI pages found, so there are no related vulnerabilities to report. This is an important check, as the shell shock remote command injection attack uses CGI pages as an attack vector. We can see that get, head, post and options are all allowed HTTP methods, but importantly put isn't shown. Should put be allowed, this may enable an attacker to upload malicious code. Nikto then runs tests to identify any vulnerabilities from the open source vulnerability database that it can detect on the target. This can take a while. Nikto's finished its scan, and in this case we find just one vulnerability, OSVDB 3233, and it's showing that the default Apache file icons readme has been found. This may indicate other default settings may exist. Let's run Nikto again, this time against a website named enterprise.htb and accessed through port 8080. Here we can see that the web server is Apache 2.4.10 and that it's a PHP website. Again we have the warnings about missing headers. We also find that the website leaks inodes via e-tags and that there's a folder /bin. In fact, Nikto displays a number of folders from the robots.txt file that we can investigate further. Nikto advises that it has found a reference to 172.17.0.3, which is an RFC 1918 address, and refers to OSVDB 630. RFC 1918 specifies the address blocks that should be used when establishing internal subnets, so this means that the address is likely to be an internal host. We can see the IP address used refers to the images folder. Nikto finds a number of other issues. Apache is outdated, indicating possible legacy vulnerabilities may exist. It responds to junk HTTP headers, and using debug may provide useful information to an attacker. Nikto also flags a full path disclosure using the WebAct servlet, and the use of ASP extensions may allow a denial of service. Nikto is identifying useful information for our testing of the enterprise server. It's a useful tool, which provides a first check of the weaknesses of a website, and on occasion can point to an easy attack that we can use. If you spend a lot of your time in Metasploit, you might want to take a look at the web analysis module called WMAP, which brings together some of the basic web scanning techniques into one place. WMAP evolved from the sqlmap tool. While WMAP is integrated with Metasploit, it isn't loaded by default. I've started up Metasploit, so let's now load the WMAP module. This loads and we're ready to configure it. The first step is to add websites to WMAP. These are going to be registered as potential targets that we can subsequently choose when running WMAP. Let's register our Europa target on 10.10.10.22 and Enterprise on 10.10.10.61. We can use the -L option to check the sites we have available as targets. These sites are persistent. Anything we add will still be there the next time we load WMAP. We've set up the sites now, so let's select the Europa website as the target. We can do this using the -T option to specify the IP address, or the -D option to select the site ID. I'll use the -D option. We've now got Europa loaded as our target, so we can run the scan using the WMAP run command. Before we do that, let's use the -H switch to get help for this command. We can see that we have the -T switch, which lists the available modules, and the -E switch to run some or all of them. Let's use the -T switch to load and check the modules. WMAP can do SSL testing, but this target isn't using SSL, so these modules are disabled. We can see we have a range of other modules for web testing. And there's a number of modules for file and directory testing, and also for unique query testing. We can select specific modules to run, but in this case we'll use the -E switch to run all modules. WMAP starts executing the tests. The first module to run is the HTTP version module, and we can see that we have an Apache 2.4.18 server on Ubuntu. WMAP then checks for OpenProxy and Tomcat, but doesn't find any files to report as the website doesn't use these services. It's also not a Drupal site, so this check finds nothing. The website supports GET, HEAD, POST and options messages, and we can see WMAP has scraped the website and found the string Apache 2 Ubuntu default page. It works. As we look down, we can see that the website WebDAV functionality is disabled. The brute force folder enumeration module runs next, looking for files and folders. The root folder is shown. As with any brute force attack, the scan for files and folders takes a while. We'll leave this running. Let's run WMAP again, this time on the Enterprise server. While sites are persistent, targets are not. Let's add Enterprise. And run. We didn't manually load the modules, so the first thing WMAP does is load them. WMAP disables the SSL checks once again, and this time we see that we have an Apache 2.4.10 server running on Debian and using PHP. Again, we don't have OpenProxy or Tomcat running, nor do we have Drupal or FrontPage. The robots.txt file is found, and the comments in it show us that Enterprise is a Joomla site. We can see the disallowed folders. And further down, we can see that WMAP has identified the internal IP address 172.17.0.3 and that WebDAV is disabled. We're again doing the brute force testing, which will take some time. WMAP brings a number of web testing modules together into one point-and-click package which, like Nikto, is useful for detecting some initial vulnerabilities and weaknesses. Let's take a look at how we approach the initial penetration of a web server using sqlmap. To do this, we'll again target the Europa server in the LinkedIn Learning Lab. First, we'll do a deep Nmap scan with the -A switch. We can see we've got 3 ports open, SSH on port 22 and both HTTP and HTTPS web services on ports 80 and 443 respectively. We're running an Apache 2.4.18 website. Port 80 presents the Apache default web page, as does port 443. We can run dir to get a quick look at what additional pages might be available. We can see the default Apache index.html and server status folder, but there's nothing else of interest. We could continue with a deep check using larger word files or tools such as dirbuster or gobuster. But before we do that, it's worth looking at our results again. We can see the SSL certificate uses the subject name europacorp.htb with alternate names of www.europacorp.htb and adminportal.europacorp.htb. This indicates we may be looking at a named server. Let's add adminportal.europacorp.htb to our host file and then navigate to it and see what we get. I'll start up Burp Suite and run Firefox through it so that we can capture and manipulate the packets. I'll then try to open the admin portal web page. I'll add 10.10.10.22 to the scope. And I'll navigate to the website. Setting the named server worked, and we've now got an admin portal login, which it would appear is still under construction. Our first port of call is an SQL injection at the admin page. It's checking for a correct format email address, and we don't get an SQL error. If we look at the page source, we can see that this is enforced by the form. Let's send in a request with a valid email address, and then check the message exchanges in Burp Suite. We can see the login GET request followed by our login post. Let's look at that. We can see that we have a post request and the credentials are at the bottom of the message. Let's give this to sqlmap to see what it can do. We can use the ---- data switch to provide the data portion of the post. Let's give this to sqlmap and see what it can do. We can use the ---- data switch to provide the data portion of the post. We can use sqlmap to check the parameter string containing the credentials. We use the ---- data switch to provide the data portion of the post, and we can also tell sqlmap that the DBMS is MySQL. sqlmap has identified the parameter email as potentially injectable and also vulnerable to cross-site scripting. We'll include all MySQL tests. SQL provides more potential details on injections with R-like, error-based and also time-based blind injections. sqlmap has identified that there are 5 columns in the query. This is useful knowledge when doing a union command injection. It's also asked us whether we want to redirect to dashboard.php. We'll let sqlmap run to completion. The sqlmap has finished now, and we can see that it's identified some injection points. Later in this course we'll see how we use this information to gain access to the server. Skipfish is another dictionary brute force attack tool, which includes website crawling as well as some web page security checks. I'll run it against the Nineveh host on 10.10.10.43. Skipfish has its own dictionary files, and we need to send output to a specific folder. I've created one called Fishy for this. We're advised this will run a brute force attack, and we can then proceed. The terminal provides a continuously updated screen of statistics for the scan. This can take a while. Let's come back when it's finished. That took a while to complete, but on the summary page we can see that Skipfish found 20 informational alerts, 1 warning and 1 low impacting vulnerability. The full report is in fishy index.html. At the top of the Skipfish report are the crawl results. Let's expand that. We can see at the main page a resource fetch failure, a missing character set and 2 new headers. We can also see a number of pages which have alerts, and we can expand them. If we click on Show Trace at the right of the server status line, we get the packet request and response details. We can press Escape to close that. At the bottom of the report, we can see the details of the issues or anomalies that have been detected. We have a signature match detected on info.php. And if we click that, we can see the details of the Nineveh server. This is a Ubuntu 16.04.1 with a Linux kernel 4.4.0 running PHP 7.0.18. In the configuration panel, we can see the host name is nineveh.htb. This will be useful for us going forward. We can use this to dig for more virtual servers in its domain. I'll close this tab now. If we click on the Hidden Files directories, we can see a summary of the hidden files and directories we've discovered. Skipfish takes a while, but it provides a good level of detail in its report. When web testing, we will often follow an exploitation chain that starts with gaining administrative access to the web server and then allows user shell to be gained on the target, and then we escalate privileges to gain root control. An initial web shell will typically use one of the many forms of active scripting code. Consequently, we need a variety of shells on hand to include in our exploits and to use as standalone modules to deliver shells. Because different targets will have different forms of active code, we need to have as many web shells available as possible. We need to be able to upload our shell file into a folder which is remotely URL accessible. For Linux Apache, this is typically in var www or one of its descendant folders such as var www html. For Windows IIS, this is typically in inetpub www root. Kali provides a number of web shells to support the various active code options. Let's take a look at them. Here we see folders for ASP, ASPX, CFM, JSP, Perl, and PHP. These folders hold different variants of the same basic shell approach. A popular form of active content is PHP. The PHP reverse shell provides an excellent approach to gaining shell access on a target. Let's see what the shell looks like. Before I do that, I'll just run a quick script to check my IP address. We can see my IP address is 10.10.14.5. We'll use that shortly. Let's scroll down past the comments. We can see the $IP and $port variables are being set. We need to change these to the callback socket that we'll set up, our Kali system IP address and our preferred port. I'll change these to 10.10.14.5 and 2222. And I'll save this as pers.php. Two other forms of shell we might find useful are ASP and ASPX. ASP is an older technology, but is a default part of older Microsoft IIS websites. Let's look at the ASP shells. Command asp.asp will allow a single command to be run via the web server. Command asp-5.1.asp is a variant of command asp.asp, which gets round an execution prevention mechanism in IIS 5.1. This uses the win.com executable to force execution of the command processor. We've got similar files in ASPX. Command asp.aspx is a popular web shell and is also known as awen. This is a single command reverse shell, again using a command field on the browser. These web shells run on the browser and don't give us a reverse command shell to work in, but we can issue individual commands, or we can execute netcat to connect to a listener to get a reverse shell. Let's check the JSP web shells. We can see command jsp.jsp. Let's see what it looks like. This shell can work on either a Linux server or a Windows server, as it notes at the top. The executable needs to be changed to reflect the target before deployment. It's set here for a Windows server using command to process Windows commands. Let's take a look at what Perl shells we have. Let's take a look at the Perl reverse shell. This looks familiar. It's a variant of the PHP script that we saw. MSF Venom is one of the most important tools which Kali provides, and it can generate a variety of web shells. We can create ASP payloads using the -f switch to specify ASP format. For example, we can create a Meterpreter ASP payload with Shikata-Garnai encoding. Similarly, we can create JSP payloads to reverse connect back to a command shell. We can then upload these implants to web servers running the respective active code, put them into its web tree, and then we can gain command or Meterpreter shell by accessing them via the URL. So we have a number of existing shells, and we can create our own. Web Distributed Authoring and Versioning, WebDAV, is an extension of HTTP that allows clients to perform remote web content authoring operations. For WebDAV sites, which also allow HTTP messages, there's a very effective tool we can use to upload a shell. The tool is called Cadaver, and it's simple to use. Cadaver supports file upload, download, on-screen display, move and copy, collection creation and deletion, and locking operations. As a pen tester, the main use we have for it is to upload a file, typically a web shell. Cadaver uses a command line syntax similar to FTP. Let's look at the manual documentation for it. It has a small number of options, but we don't need to use any of them. We can see that it supports the ls and cd commands, as well as displaying the current working directory. The put and get commands are the commands we'll use most. We can see there are a number of commands relating to collections, which are to all intents and purposes folders managed by WebDAV. We can also see the cat command, which allows us to display a file. Let's take a look at the Granny server on 10.10.10.15 and run a Nikto check. We can see that the server website is still under construction, and there's nothing for us to work with here. I'll let this run. We can see that this is powered by ASP.NET, so we know the kind of shell that we want loaded. Nikto reports the OSVDB397 vulnerability, that the server supports the HTTP method put, and this allows clients to save files on the web server. We can also see that it has DAV headers. As this has DAV headers, let's use the nmap WebDAV script to see whether WebDAV is supported. The HTTP service has a number of risky method types, including put, and it supports a number of WebDAV methods. Let's see what we can find using Cadaver. Okay, we get the DAV prompt, so we're in business. I'll run the ls command to see what's in the folder. We have a number of folders and the iisstart.htm file. This is the web root. We have ASP and ASPX command web shells, so I can upload one of them. I'll use the ASPX command ASP shell, and I'll save it as a1.txt. This is a technique we can use to avoid the shell being executed as we're uploading it, as all we'll get in that case is the execution output. OK, we've uploaded our ASP shell. Now let's rename it using the move command. Note that Cadaver also supports the copy command. Now we can navigate to our A1 shell. And we get a command prompt box. Let's enter the who am I command. OK, at the left we can see we're the NT Authority Network Service. This isn't a privileged account, but we do have command execution access. Let's run the dir command, and we'll use 8-character DOS file names. And we have the list of user folders. Cadaver is an extremely useful tool for web dev sites and makes gaining shell access fairly simple. It doesn't provide privileged access, so there's more work to do, but having a shell or a command execution is a great start. Sometimes a challenging problem can be solved with some basic checks. And for the web pen tester, one of the simplest is to check the page source to see whether there are any clues. Let's take a look at the calamity server at IP address 10.10.10.27. When we run an mmap, we see that ports 22 and 80 are open. Navigating to the website, we see it's a Brotherhood software site, which is under development. If we check the page source, it doesn't reveal a great deal other than some strange comments in the code. We'll not get any further here. Let's use dir-b to do a quick check for hidden pages. We can see that admin.php, index.html, server status and uploads have been found. Let's take a look at admin.php. This invites us to log in to the administrator page. If we check the source, we find that it seems to have the user and password swapped. So if we have credentials, we need to use them in the opposite way. It's also interesting to see that the page has a scroll bar, yet there's no long lines of text. Let's scroll. Here we see a comment that provides us with the password. Let's close this and try and log in with the standard username admin and this password, remembering the fields are labelled incorrectly. OK, we're in. This is an interesting page from a somewhat disgruntled employee. But the most important thing is we have an HTML entry box. Let's enter some HTML. OK, we're running HTML. It's worth checking now whether HTML supports an active scripting language, perhaps PHP. Let's try a PHP echo command. Yep, it supports PHP. Let's create a simple PHP Meterpreter reverse shell using MSF Venom. Our IP address is 10.10.14.5 and we'll use port 2222. We have the PHP code. Let's copy it. Before we paste it and run it, we'll need to set up a Meterpreter listener in Metasploit. We'll use the multi-handler and we'll set the payload to PHP interpreter reverse TCP. We'll set lhost to 10.10.14.5 and we'll set lport to 2222. And we'll run. Let's paste the PHP script into the box and execute it. And we've got a interpreter session running. Let's activate it. And let's check the system information. I'll drop into a shell and find out who I am. I'm www data, so this isn't a privileged shell. Nevertheless, let's look at the home folder. And we've got a user, Zalvas. Let's look at the Zalvas folder. And amongst other things, we can see user.txt. And we have the user token. Calamity shows us that checking the simple things can sometimes save a lot of effort. Not all penetration requires complex exploit activity. We've been able to get into a full user shell and retrieve the token with relatively little effort. We'll often see PHP being used on websites, and we have PHP web shells that we can use in our testing. Previously, we used the PHP reverse shell to create our own pers.php. Let's take a look at the website on 10.10.10.68. I'll run the web access through my Burp Suite proxy. I'll switch intercept off, and we'll add 10.10.10.68 to the scope. At the website, we're presented with a Rexel's development site, and it looks like a PHP bash site. This is a website which presents information on a tool called PHP Bash, which can be used to enable easy remote bash scripting on a server. If we click the arrow, we can see two images of using PHP Bash. Let's see what we have in Burp Suite. If we open the website on the left panel, we can see we have the root page and a few web pages, demo images, and JS. If I right click and spider, the only additional page we see is CSS. There's nothing here for us to work with, it's just a display site. Let's run derb to do a quick top-level brute force and find any additional web pages that might exist on the server. Okay, we'll let that run. Derby has found a number of pages for us: CSS, dev, fonts, images, JS, PHP and uploads, as well as the standard index.html and server status files. We'd expect some of these, but the dev, PHP and uploads pages may be interesting. Let's go take a look. Let's check out uploads for a start. There's nothing here for us right now. Let's look at the PHP page. This has just one file called sendmail.php. This may be useful to look at later, but we'll leave it for the moment. Let's look at dev. This has two files, phpbash.min.php and phpbash.php. It looks like this site isn't just providing information on PHP Bash, but it has an operational PHP Bash capability. Let's click on phpbash.php. We've now got a command line at the bottom of the screen. Let's check who we are. We're www.data. This is an unprivileged command execution. Let's see what user accounts we have. We have a Rexel and Script Manager. And in a Rexel's home folder, we can see the user.txt user token. And we can display its contents to get the user token. We've not had to upload a shell because we have a command line execution using the PHP bash tool, which had previously been used on the web server and not removed. Using this, we've gained the user token and can now look for a full user shell and then privilege escalation in order to gain full root access. Node.js is a web server technology built using Chrome's V8 JavaScript engine. It uses an event-driven non-blocking communications model that makes it lightweight and efficient and suitable for large-scale web use. This is supported by an open-source library called npm. Node.js is used to collect forms, data, generate dynamic page content, and manipulate files and databases. A Node.js module is started using the node command at the command line and will associate to a port. The module will be executed to process messages when a user connects to that port. Node.js is a form of Java engine. The key difference between JavaScript and Node.js is that execution of JavaScript occurs at the client, whereas Node.js runs JavaScript on the server. Let's take mmap to look at the target 10.10.10.85. We've found one port open, port 3000. This is shown as the Node.js Express Framework service. I've got Burp Suite active and proxying, so let's navigate to the Node.js service. We get a simple message telling us 2 + 2 is 22. We can see the message in Burp Suite, and we can see there's an element profile equals. I'll highlight the contents of the profile line and send to decoder. In the decoder, I'll decode this as base 64. And we get a set of identifiers and values. Let's change the values. We'll make the username Akhtar, the country Australia, and the city Melbourne. And we'll change the number to 4. I'll put in a curly bracket and get rid of the trailing characters. I'll then encode this as base 64, and I'll copy the resulting string. I'll go back to the target screen, and I'll right-click on the message and send it to the repeater. And in the repeater, I'll replace the profile with the new base 64 string. When I press the Go button, the request is sent to the Node.js server and the response is returned. Hey Akhtar, 4 + 4 is 44. We're now actively interacting with the Node.js server. Let's take a look at Adrian Abraham's GitHub site, where he provides a Node.js reverse shell. We can see the usage instructions at the start of the code. We can use this to gain shell access to the server. I've copied this into my root folder and called it nodejsshell.py. I'll run the script with my IP address and use port 2222 for the reverse shell. Okay, that provides an immediate eval function which we can use. We can exploit a deserialization flaw by using this. We need to set this up as a Node.js list using the RCE identifier providing a leading string $$ND func $$. Note that we've set this up as the value of RCE and that we've included brackets at the end of the value string. I'll copy this, I'll paste this into the encoder and encode it as base 64. And I'll now copy this. Before we send it, we need to open a listener on port 2222. Okay, let's copy it into the request and we'll send it. We can see the response says invalid user type. This is expected. Let's check our listener. And we can see the message connected. Let's find out who we are. And we're Sun. Let's find out where we are and what's there. We're Home Sun. And we can see the user folders and files. Let's look at documents. And we can see two files, script.py and user.txt. And when we cat user.txt, we get the user token. Node.js sends commands to the server using base 64 encoding. By intercepting a message and replacing the data being sent, we can interact with the Node.js server. When combined with a usable vulnerability, this provides an ideal access path to get a shell. Previously in the course we used sqlmap to identify the SQL server on Europa as being MySQL and to determine that there are 5 columns in the login query table. We also found that it was possible to get a redirect to dashboard.php using an inject. I've got Burp Suite running as a proxy for this website, so let's go to Europa again and enter a random set of credentials, which we know will fail. We can see the messages in Burp Suite, so let's select the login page post request, right-click and send it to the repeater. We can go to the repeater and use the knowledge we got from sqlmap to inject a union command into our request. We know the website is vulnerable to a union attack with 5 columns. I'll use the phrase quote union all select null 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 hash for both the email and the password. We'll need to set the content length correctly. This data line is now 104 characters long. We can now press Go to send the packet. This time we got a 302 response, which sets the session up to redirect to dashboard.php. We need to go back to Firefox and refresh to get this to happen. And then we're redirected into the admin dashboard. We successfully used Burp Suite to inject an SQL union command to circumvent the authentication and deliver admin website access. Let's take a look at how we approach the penetration of another web server. For this, we'll use the target at 10.10.10.29. The first step is to enumerate the services using mmap. We see that ports 22, 53 and 80 are open. Let's take a look at the web server. We can see that we have a default Apache website page, so there's nothing for us here. We'll need to look at what else the server might have to offer. We have port 53 open. This is a bit unusual, but we've seen it before as a way to support named websites. In this case, we might guess this is a named website called bank.htb. In the real world, we'd find such clues by analysing traffic and finding multiple sites using the same IP address. Let's test this by adding an entry of bank.htb to our hosts file. I've already set Burp Suite up to be a proxy, so I'll add bank.htb to the scope. Now let's visit bank.htb and see if it's a named website. And we have an active website with a login page. We can use the dig tool to identify all websites on this host. And we can see bank.htb, www.bank.htb, ns.bank.htb, and chris.bank.htb are all managed on the site. For the moment, we'll concentrate on bank.htb. Before we try any attacks to break in, let's complete our initial enumeration. We've seen that we can use Burp Suite to enumerate the site. However, even with this initial page, without credentials, Burp Suite can't see deeply into the website. So we'll start by using another tool to look for additional pages. We've seen how we can use Derby, Dirbuster and GoBuster as tools to search for hidden pages. Let's have a look at another tool called dirsearch. Dirsearch is a Python script available by git cloning from the Mora Soria site here. I've loaded it into my user share folder so we can run it from there. It's a Python 3 script, so we'll run it using Python 3. We'll set the host name to bank.htb and use the medium dirbuster word file. We'll also do the same as dirbuster and look for PHP files by setting the -fe switch. We can have this run faster by setting the number of current threads, again as we would in dirbuster. We'll set this using the -t switch to 25 threads. We can see the index.php comes up quickly, as do the folders, uploads and assets. We can also see login and support PHP files. This is moving along nicely, but it's going to take a while to run, so let's come back when it's finished. A number of PHP scripts have been found by dirsearch. Index.php, login.php, logout.php and support.php. A number of web pages have also been found, including uploads, assets, Inc., and an unusual one called balanced transfer. With this in mind, let's take a look at some of the website contents. First we can check uploads, but we aren't authorized to see this folder. We can check assets, and we see a directory listing of the kind of resources we'd expect in a website. When we look at the hidden folder .php, again we don't have the authorization to access it. We can check balance transfer, and we can see a list of random file names with an ACC extension in balance transfer. This displays the file details. It has a message saying ++OK encrypt success and has encrypted data for the name, email and account password. There's nothing we can do with this as it stands, and given this looks very much like encrypted data and not base64, we won't do any more with it. Back out in the folder, we should just check whether there's anything else of interest here. As we scroll down, we can see the files are all similar and within a few bytes of being the same size. Here's one that's different. It's only 257 bytes long. Let's take a look. This has a message saying error encrypt failed, and it has the data in plain text. We can see an email address and we can see a password. Good for us, but bad for Chris at bank.htb. Let's go log into his account. We now have online access to this account. On the left side we can see two links, Dashboard, which we're on, and Support. Let's look at Support. And here we have the support page where we can upload a file. We've got a reasonable idea of the layout of the bank website, and we know the main site presents a login page. Let's look at the support.php file. When we go here, we get a redirect back to the login page. Let's take a look at this in Burp Suite. If we highlight the get message for support.php, we can see the request message details in the bottom panel. If we look at the response, we can see that we get an HTTP 1.1302 found message, which is a redirect. A little further down the message, we can see the line location login.php. This then is how the redirect works. If we scroll down the response further, we can see that the message includes the HTML code to create the support page. If we select the Render tab, we can see that page. Gaining access to this code would enable us to upload an attachment. Let's see how we do that. I'll click on the Proxy tab and turn on Interception. We'll select the Options tab and set Interception off for requests. And set Interception on for intercept responses. Now let's go to the support page again. The website is waiting for a response, so let's go to Burp Suite. We can see the Proxy tab is lit up and there's an intercept waiting for us. I'll remove the line location login.php and forward the message to let it go out to the browser. We can see that we have a success. We can achieve the same result by automating an intervention using Burp Suite. At the proxy page, let's turn off interception. And in the Options tab, scroll down to Match and Replace. We can add a new rule. Select Response Header, then enter 302 found as the match and 200 OK as the replacement, and press OK. We now have a new rule at the bottom entry, and it's checked as active. Back in Firefox, we can again go to bank.htb supports PHP and this time we get the support page sent directly through without intervention. Okay, we've done our reconnaissance and used that information to find 3 different ways to gain website user access and get to the point at which we can upload a file. That's the first stage of our penetration complete. We've got credentials to access the website, so let's go log in. And let's go to the support page. We know we have a PHP website, so our initial objective will be to get our pers.php file up to the website. Let's submit a ticket. Okay, we get a message saying this has to be an image. We not only know how to create an image file that has an embedded PHP using JHead, this was covered in the Advanced Kali Linux course, but we have one ready to go. Let's use the nsa.php.jpg image with embedded PHP that we created and upload this. And submit. Okay, we've successfully created our ticket. Now when we click on the attachment, we should see the NSA image. We do. If our uploaded image is active, we can now add a command to the command line and we should see the PHP code being executed. Sadly, we don't get execution. Either the image has been corrupted during the upload, or the server has restricted what we can do. Let's have a look in Burp Suite to see what's happened. When I select the second post to support.php, I can see my nsa.php.jpg upload in the request message. Let's look at the response message. As we scroll down, we can see a comment which says, "Debug, I added the file extension HTB to execute as PHP for debugging purposes only." Okay, so it looks like we can execute PHP as long as it has an HTB extension. I'll turn Intercept on. Let's go back to our support page and run the upload again. And submit. We've got the message waiting for us to send it on its way, so we'll change the name of the uploaded image to nsa.htb. And press forward. In fact, you'll find that you can just change the name of your PHP JPEG file to a .htb and upload that. As long as it's got an image header, it will be uploaded. Okay. We can see we don't have the image rendered, but we do have a clear screen. Let's update the URL to include the whoami command. Okay, we get a blank screen. Back in Burp Suite, we can see the GET request with $command equals. And in the response, we can see that whoami has returned www-data. We now have a way in, even if it's not on screen. Let's set up a listener on 2222 and then send a netcat command from the URL. And we've got a connection. We're www-data as expected. And there's a Chris folder under Home. As expected, we can gain the user token from user.txt in the Chris folder. Okay, let's have a look round. We have the normal top-level folder, and we've seen what's in Home. Let's have a look in Temp. Nothing of interest there. Let's have a look at var. Okay, we have a bit to look at here as we'd expect, including a var level HTB folder. Let's have a look at that. And we have a file called emergency in that folder. I'm a bit curious about what's in there. Okay, it's a bash script to get root. Might be interesting to see if we can use it. First of all, however, I'll run my standard Python command to get prompts. And we'll answer yes, we do want to get a root shell. Now we can list the root folder and we can see root.txt. And we have the root token. We now own the bank. Previously we looked at how to enumerate Europa, to use sqlmap to provide vulnerability details, and then to use an SQL injection to get access to the admin portal. We'll now look at how we use this admin portal access to gain full control of the server. Credit to v3dead for the initial code execution and PentestMonkey for the reverse shell code. We're at the admin portal dashboard, and I have Burp Suite running as a proxy. Let's select the Tools link. This brings up a script, which is a template for creating a VPN connection. We can see there's a box to enter an IP address, and we can see in the script the places where this will be inserted. Let's put in an IP address, anything for this test, and then press the Generate button below the script panel. We can now see the generated script. In itself it's not much use to us, but let's look at what we can see in Burp Suite. Let's look at the post message to tools.php. We can see the element pattern shows IP address, which we expect to be replaced, and the IP address field as the IP address we typed in. This is in fact going to be processed in a PHP regular expression replacement function preg_replace. There's a known feature, vulnerability or backdoor, in preg replace, which allows execution of PHP code. This is triggered by using the e command after the pattern. So we can replace the data we see with the string pattern equals /thing1/e ampersand IP address equals system lsal and text equal thing2. In practice, we'll need to replace the 2 forward slashes in pattern with the %2f hex representation. Let's go back and run the generate again, and this time we'll set intercept on and catch the message so we can replace the data. I'm back at the tools screen and intercept is on. Let's enter the IP address and generate. Okay, we can see Firefox is waiting for its response. Back in Burp Suite, we have the message intercepted. Let's replace the data with our replacement string. Okay, this string is 68 characters long, so we've replaced the content length with the value 68. We can now turn off intercept and the message will go. Back in Firefox, we can see we've got our root directory listing. Let's do that again, this time with the string ls-al/home. And the length is now 72. We've now got our home directory listing. There's just John. We know there's likely to be a user.txt in the home directory, so let's do this again and use cat to type it out. I've updated the content length to 83, and again we can turn intercept off. And now we've got the user token. Okay, so getting the token is fine, but we really want a shell. It turns out that Europa doesn't support the -e option on Netcat, but there's a neat way to use the FIFO special file to achieve a shell. We'll enter the following string. We can see this removes the FIFO file if it exists, and then makes a new one, and then uses it in conjunction with Netcat to connect to our listener. I'll set up a listener. I've updated the content length to 143, so we can now turn off intercept. Okay, we've got a shell. It's www data, so it's a user shell. We now have a user shell on Europa, and we know it's a PHP server. The first thing we'll do is upload pers.php so that we can have easy re-entry. We're in var www.admin. We need to experiment a little, but it turns out we don't have permission to create a file here. We can see we have some directories, and by trial and error we find out that we can write into the vendor folder. I'll set up a listener which will upload pers.php to this target. Back in Europa, we'll connect and upload with a 3-second timeout. Okay, we've uploaded pers.php. We'll be able to re-enter at any time using the URL https admin portal Europa Corp htb vendor pers.php. Okay, getting back to escalating to root to get our root token, and in fact a root shell if we wish to do that, let's take a look at var www. We can see 4 folders here: admin, command, cronjobs and HTML. Let's look at cronjobs. We've got a file called clear logs. Let's see what's in it. Okay, it's a simple PHP script to open the access.log file and then clear it. It also then runs a shell script from the command folder called logclear.sh. We can see from the folder listing that we don't have write permission to this folder, so there's nothing we can do with this file. Let's go look at the logclear.sh file. The folder is empty. The shell file to run after clearing logs hasn't been set up. We can also see we have write permission to write into this folder. Assuming the cron job runs at system privilege level, let's create a logclear.sh file which will copy the root.txt file into our vendor folder. We'll also have to change the destination file permissions so that we can read it. Let's check this to make sure it's what we want. Now we should also make it executable. All we have to do now is wait for cron to run this. Let's go to the vendor folder and check. Okay, it's here. And we have the root token. Of course, if you wish to take this further, you can now change the logclear.sh file to create a reverse shell by using the same FIFO technique that we used in the injection, and then we'll have a root shell. The days of monolithic development in a waterfall model are now giving way to the new forms of continuous integration, continuous development, CI/CD. One of the popular tools for managing integration is Jenkins. Let's take a look at testing a Jenkins system. Jeeves is a hack-the-box server on 10.10.10.63. Let's see what it looks like with Nmap. Nmap identifies 4 ports: 80, 135, 445 and 50,000. Let's look at port 80. Okay, we get a search page called Ask Jeeves. Let's put in a search term. And we get an error. If we go back and look at the page source, it appears that this is the action for any search. It looks like we won't get anything here. Port 50,000 is shown as a Jetty service. Jetty is an open source web server which has been developed as part of the Eclipse Foundation, and it's used in a number of different solutions. Let's navigate to it to see what's there. Okay, we now get an error with /dot not found. We need to do some trial and error testing, and with some luck we'll eventually decide to try to use /askjeeves as the URL. Now we're in business. We have a Jenkins dashboard. While we have a login prompt, we seem to have functionality without that. We can click on the hyperlink for Manage Jenkins, and we get a number of options shown. Let's look at Configure System. This provides configuration information. If we look at shell executable, we see it's blank. Let's change that to C:\Windows System32 command.exe. And press Apply. Let's go back to Manage Jenkins. And as we move down, we find the script console, which allows us to use Groovy scripting for diagnostics and support. This is a good place to start testing the system. The first thing we'll do is just to run a single print line command. And then we can press Run. If we scroll down, we can see the string has been displayed. Okay, we're running commands through the scripting console. At this point, we'd either be familiar with Groovy scripting or would invest a bit of time learning it. The next thing we might try is to print the system information. Scrolling down, we can see that this is a Windows 10 Pro build. Unfortunately, the execute approach doesn't work with any inbuilt commands, so further research is required to find a method to execute commands. We can do this with the process builder. This code creates a new process with arguments which run the command.exe program, which then takes the dir command as an argument. Let's press run. When we scroll down, we can see the directory listing. We can see a file called secret key, which we really need to look at. Let's change dir to type secret key and rerun. And we can see the secret key. Okay, let's check on the users by running the command dir users. And we can see there's a number of folders, including one called Kosuke. We know that on a Windows system the user.txt file is in desktop, so we can try to access it directly. And we get the user token. In the original directory we saw a folder called secrets. Let's look at it. We can see a file called master key. Let's look at that. And we get the master key. There was also a file, initial admin password. And we get the contents of initial admin password. With this configuration, use of the admin console was not locked down, and we were able to use Jenkins' Groovy scripting capability to get command execution. We haven't worked out the way in which we can use the various key material we've extracted, but we've got the user token, and we've set the foundation for working towards full control of the server. A content management system, or CMS, is most often seen as a web-based application which provides a framework for rapid development of a website without needing to understand complex HTML constructs. It will have a number of modules. The first is the Web Content Interface, which allows a user to add the text, images, video, audio, and so on required for their website. The second is the Content Delivery Application, which processes the stored content and creates the website pages. A CMS will have a database backend, which holds the content, and other capabilities such as an administrative tool, wizards, logging, and so on. One of the popular personal CMS systems is WordPress, designed for individuals to create their own personal website with an emphasis on third-party plugins and used extensively for blogging. The large ecosystem around WordPress means that users don't have to have specialized knowledge, as whatever they need to do is likely available as a standard plugin. Joomla and Drupal are two other more sophisticated content management systems, often used by businesses. These have strong collaboration capabilities to enable distributed content development. Each CMS system works differently. However, they all deliver content which is created and accessed through a web browser. The web developer adds or modifies content through the developer portal, and this updates the backend database. The content framework will usually add the links that are required to render that content in the appropriate place on the website. Some CMS systems enable changes to be published in real time. Others may be designed such that many developers can change and submit content, but only the site administrator can review and publish. Early versions of CMS provided a limited ability which enabled users to create simple websites, and anything more complex had to be coded by hand. Websites are now mostly developed using content management systems. Contemporary CMS systems are feature-rich and enable much more complex websites to be built. And for many, there's a thriving ecosystem of plugin modules to add sophisticated functionality at the click of a button. There are many open-source content management systems such as WordPress, Joomla, and Drupal. There are also some highly respected commercial systems such as Sitefinity and Sitecore. Given their widespread adoption, it's now important for a pen tester to be not only familiar with content management system concepts, but also to have hands-on experience testing them. From a pen testing perspective, by managing the technical content development, a CMS avoids many of the simpler mistakes that may occur in a hand-coded website. However, CMSs have two features which a pen tester will want to check for flaws: the ability to plug in active content such as PHP, and the fact that users may store sensitive information such as credentials unprotected in the backend database. Let's take a look at a couple of the open source content management systems. WordPress is a very popular content management system for individual and small business users. However, it's not without its problems, both in the way it gets installed and also with some well-publicized exploits. There's a fair few exploits here. In fact, there's over 1,000 covering the web application and its many plugins. Let's take a look at the Hack the Box Enterprise system on IP address 10.10.10.61. I'll be using some of the exploitation work carried out by Alamot to demonstrate testing for this content management system. Earlier in the course, we used MassScan to do a rapid scan of this target. We found 5 ports open: HTTP on ports 80, 443 and 8080, SSH on port 22, and an unknown port 32812. Let's do some deeper probing using Nmap. We fairly quickly get a response. SSH2 is shown in the fingerprint for port 22. We can see the web servers are Apache 2.4.10 on HTTP and Apache 2.4.25 on the HTTPS ports. We can also see the site seems to be focused around the USS Enterprise. Further down, port 8080 is supporting a Joomla service using Apache 2.4.10, and we can see port 32812 is a library computer access and retrieval system, the fictional operating system used on the Star Trek series. Let's look at the websites and do some basic website enumeration. If we look at port 80, we can see the USS Enterprise. Let's start enumerating the website at port 80 using GoBuster. We've found a number of PHP files and folders, including WP content, WP admin, and wplogin.php. These indicate that this is a WordPress site, and if we had credentials, we could log in through the wplogin.php page. Let's check the HTTPS site. The HTTPS service just serves up the Apache default page. Let's see if we can find anything else here. We'll again run GoBuster. We've found a folder called Files. Let's take a look at it. The Files folder contains a file lcars.zip. We can click on it and open it. Here we have 3 PHP files. If we open lcars.php, we find a couple of interesting things. We have a computer name, enterprise.htb, and this is an lcars plugin. This is indeed a WordPress plugin in the Star Trek theme of the website. The lcars PHP file also notes that the database interface needs to be secured. This could be a way in for us. Let's take a look at the lcarsdb PHP file. We can see this takes a parameter called query. WordPress holds its plugins in a folder called WP Content Plugins, and we know it uses MySQL as its backend database. Let's use sqlmap to test lcarsdb with a random value for query. sqlmap finds that the parameter query is vulnerable to injection. Let's try an injection to get the databases. This retrieves 8 databases, and interestingly we can see Joomla here as well as WordPress. We can dump the WordPress database. This takes a while as it dumps the whole database. We'll let it run. As we scroll through the database output looking for anything interesting, we eventually find an entry saying, "Needed somewhere to put some passwords," followed by a number of complex passwords. Further down, we can see a name and email address for the user William Riker. OK, let's go to wplogin.php and try it. We could try all the passwords, but in the interest of time we'll go directly to the one beginning with use star. Also, in the interest of time, I've added enterprise.htb to my etc hosts file, as the website will require this. And we have access to the website, and we can see the draft message regarding storing of the passwords. We've previously managed to gain access to the USS Enterprise WordPress site. We can see the dashboard provides a series of functions down the left that we can choose from. Let's take a look at plugins. We have the option at looking at installed plugins, adding a new one, or editor. If we do some research on plugins, we find that they're little more than a PHP script. We already have our shell PHP script, so we can use a WordPress variation of that. All we need to do is change the beginning of pers.php with the header shown here. I'll copy this header. I've created a plugin called wplug.php using this header and copied in following that the standard Kali PHP web shell. I've updated my IP address and port, and I'll change the name to Shelly. We now need to zip this because WordPress loads its plugins as zip files. Before we load the plugin, let's set up a listener. Let's select Add New. We can ignore the error. We'll just select Upload Plugin, select our wplug.zip and press Install now. And let's activate the plugin. Back at the listener, we now have a shell. And we're www data. Let's check for our user token. We'll need to see what users are registered. We just have user.text. We'd expect to see a username here. So we don't have a token, but a message telling us we're in the holodeck. After a bit of looking round, we can do a full listing of root. And at the top we can see an entry .dockerenv. We are in a kind of holodeck. We're in a Docker container. To go further, we'll need to break out of this container and get into the underlying system. We'll leave that challenge for another day. To recap, we've been able to find a way into the WordPress site, gain credentials, and use its plugin capability to get a shell. We've previously managed to gain access to the USS Enterprise WordPress site. In doing that, we detected that the server was running a Joomla content management system on port 8080. I'm running Burp Suite as a proxy, so let's go look at port 8080. Okay, we've got a 10 forward website. If we look at the target sitemap, we can see the URL in the left panel. Let's expand it and spider it. Okay, we've got a lot more pages now, including one called Administrator. We'll come back to this. Let's revisit the sqlmap list of databases that we found when looking at WordPress. Okay, we have Joomla DB. Let's go look at it. We have quite a few tables here. We can see there's one called EDZ2G users. That sounds useful. Let's have a look at its structure. And let's get the usernames and passwords. And we see we've got Guinan and Jordi Laforge. And Jordi Laforge is a super user. We've got password hashes. We could try cracking the password hashes, but we already collected the plain text passwords from the WordPress database. Back at 10 forward, we can see that we have a login box. We know the password starting use* belongs to William Riker. So let's try the second password that we collected, the one beginning ZD. And we're in. We have access, and we can see the blog page. However, this isn't an administrator portal. We saw there is one, so let's log out and go to that. And we're into the Joomla administrator portal. We've previously extracted a superuser username and password using sqlmap, and we've used them to gain access to the Joomla administrator portal. Now we're in the portal, we can load ActiveCode user extensions into Joomla as templates. Let's select the templates option. Here we see two templates, Bees3 and Protostar. Let's select Templates. And let's take a look at Protostar details and files. We can see we have a number of components, including folders and PHP files. We also have a copy option on the top left. Let's copy this to a new template that we'll call Shelly. If we go back to the templates, we can now see the Shelly details and files. I'll select it and go down and look at the index.php file. Let's replace this with our Kali PHP web shell, configured with our IP address and set for port 2222. We'll cat the pers.php shellcode and copy it. And we'll delete the existing code and copy our shellcode in. We can save this now. Let's set up a listener for port 2222. And let's navigate to our new template. and we have a shell. Again, we can see we're in a Docker container. We've got a shell open in Joomla, so let's go to the website folder. We can see quite a few files here. Interestingly, we see the Files folder. When we enumerated the folders on the 3 website in the enterprise server, we saw that the secure website on port 443 presented the Files folder. The Files folder then provides a bridge between the real website on port 443 and the Docker container on port 8080. Let's see what we can do with it. The Docker container is something of a challenge, as it doesn't have netcat, wget or similar utilities loaded, so we can't easily bring in our shell files. Even using echo to drop content into a file doesn't help, as certain types of content gets filtered out. However, let's see what we can do. We can also see a file called WordPress shell.php. Sure enough, this is the Kali PHP web shell. Given that it's here, and given that we have something of a challenge otherwise, we might as well use it. Let's copy it to Files and give it a simpler name. When we displayed the file, we saw that it was set up for 10.0.8.2. We need to change that. We can use sed to do that. We'll also change the port to 1111. Okay, let's set up a listener. We can now navigate to our script on the secure website's file folder. And we have shell. Now we can look at the real home folder. And we see there's a home folder for Jean-Luc Picard. Which contains the real user.txt. Which contains the user token. We've now got a user shell through which to take the first level of control of the USS Enterprise. I'd really like to thank you for joining me for this course. I hope you enjoyed learning what is a qualified pen tester. Web is an attack surface which is part of most businesses, and with this course under your belt you have a great foundation of knowledge to use in your testing. You can take additional advanced courses in the pen testing series. If you haven't taken the Advanced Kali course, then that's a must. The series includes additional courses to further develop and practice your skills around deep enumeration and to get more understanding of exploits. These will all help in your preparation for taking the OSCP examination. There's always something new in cybersecurity, and if you're interested in learning more, then check out the full security segment of the library, where new courses are added regularly. You'll find courses on all aspects of security. I'd also invite you to go to my author page, where you can find some additional pen testing courses, as well as a wider coverage of cybersecurity. If you want to get hands-on with Android, then do take a look at mobile devices and platforms and securing Android apps. If you're wanting to learn about security for the cloud, then cybersecurity for cloud computing is for you. You'll also find courses on the security aspects of wireless and the Internet of Things. You've been introduced to Hack the Box through the LinkedIn Learning Lab. You can use the switch function in your Hack the Box page to gain access to the full Hack the Box lab, which is free to use. I would recommend, however, signing up for the very modest cost of the VIP lab, which gives you access to many retired machines that you can work on to develop your skills. Thanks again for joining me on this course, and I hope to see you again soon for more courses on pen testing and cybersecurity.